In this video, we're going to look at two special cases of straight line graphs. If you have a look at them, you can see that they look slightly different to the ones we've seen in the past. So if we have a look, we can see that there is a y-intercept, but there seems to be no x-intercept because it doesn't cut the x-axis at any point. So let's see if we can find out the equation of this graph. If I have a look at this coordinate over here, I'll see that my x value is -5 and my y value is 2. Over here, my x value is -3, while my y value is still 2. There, my x value is 1, my y value is still 2. Over here, I can see that my x value is 3 and my y value is still 2. In fact, the one thing that is consistent throughout here is that no matter what x value we're looking at, y is always equal to 2. In fact, that is the equation for this graph. That is enough to describe the whole graph. So we've discussed what that means for the x-intercept. There is none. And we can see that our y-intercept is 2. But what does that mean for our gradient? Well, if we recall, we can calculate our gradient by saying y2 minus y1 over x2 minus x1. So let's pick 2 points. I'm going to make this point 1 and this point 2. So I'm going to say 2 minus 2 for my y values and 3 minus 1 for my x values. That's going to give me 0 over 2, which is going to simplify to 0. So the gradient here is going to be 0. All horizontal graphs will have an equation of y equals a number, and the gradient will always be 0. Think about it this way. If you were walking across a completely flat surface, you would say that there was no slope. And similarly, since this is a completely flat graph, there is no slope, and the gradient is then 0. Okay, so that's the first type of graph we're looking at. Let's hop on to the second. Here, we're looking at a similar graph, but instead of a horizontal, we have a vertical. Once again, we can check various points on here. Here I can see that my x value is 4, and so is my y value. Here I can see that my x value, once again, is 4, but now my y value is 2. Here, my x value is still 4, and my y value is -2. And over here, my x value is still 4, and my y value is -4. Here, what's consistent is that x is always equal to 4, regardless of the y value. So the way we describe this graph is by x equals 4. In fact, vertical graphs are all described by x equals a number. Here we can see that the x-intercept is 4, but that there is no y-intercept. This graph never crosses the y-axis. What about the effect on the gradient? So let's do what we did before, where we calculate it using any 2 points. You'll notice that regardless of which point you choose, this will work out to be the same. So I'm going to use these two over here. Let's make this point 2 and this one point 1. So at the top, I've got 4 minus 2. And at the bottom, I've got 4 minus 4, which gives me 2 over 0. And this should be a huge red flag for you. We cannot divide by 0. It gives us something that is undefined. So actually, what we're saying here is that this graph has a gradient which is undefined. In general, we're going to say that all vertical graphs have the equation x equals a number, and their gradient is always undefined. So let's just summarize what we've seen. For a horizontal straight line, it always has the equation of y equals a number, and the gradient is always 0. For a vertical line, we always have the equation in the form of x equals a number, and the gradient is always undefined. And that's what you need to know about those two special graphs.